All right, we're about to dive into this absolutely wild, microscopic, high-stakes race against the clock. It's a story of survival against just incredible odds, and it all kicks off with a really fascinating biological paradox. So here's the central puzzle right off the bat. It seems completely backward, doesn't it? Sperm need one type of environment to survive and do their job, but their journey starts in its literal polar opposite. It's kind of like asking a fish to start a marathon in the middle of a desert. So how on earth does this system actually work? Okay, so first things first. To really get a grip on the journey, we have to understand the traveler. What makes sperm tick? And why is this preference for an alkaline world so absolutely critical to their mission? And wow, you can really see the two extremes right here. It's like night and day. In their happy place, this slightly alkaline world, sperm are basically supercharged. Their energy production is firing on all cylinders, their tails have maximum power, and they're swimming with real purpose. But you drop them into an acidic environment, it's a total system shutdown. Their energy gets blocked, their sails just stop, and they're pretty much stunned into place. You know, this isn't just some casual preference. It's a core design feature. It's baked right into their biology. The tiny little engines that power the sperm's tail, which are fueled by something called ATP, and the channels that control its movement, they are all perfectly calibrated to work at their absolute best in alkaline conditions. If you take that away, you're basically taking away their ability to move at all. This analogy just hits the nail on the head. It's perfect. A sperm isn't instantly destroyed by the acid, but it is completely immobilized. It's like a runner who suddenly can't breathe. They're not gone, but they sure aren't going anywhere. So given this massive, massive obstacle, how does it ever work? Well, it turns out nature has this incredibly clever three-part strategy to overcome what really seems like an impossible challenge. So here are the three keys to survival. First up, they get a temporary shield. Second, it is a desperate, frantic race against the clock. And third, they get a little bit of a helping hand from the female reproductive system itself. Let's break each of those down. The very first line of defense is the fluid that carries the sperm in the first place, semen. See, semen is alkaline. So when it enters the acidic vagina, it acts like a buffer. It temporarily neutralizes the acid right around the sperm. It's like they're wearing a protective suit that gives them this brief but absolutely crucial window of opportunity to get moving. But here's the catch. That protective suit does not last long. The vagina is just the starting line. It's not the racetrack. The healthiest, strongest sperm know they can't hang around. They use that temporary protection to swim like mad toward the much safer environment of the cervix, a destination they have to reach within just a few minutes. And this is where it gets really interesting, because a little teamwork comes into play. The body actually anticipates this journey. During a woman's most fertile window, right around ovulation, two things happen. The vagina becomes a little less acidic, and the cervical mucus becomes thinner and more alkaline. This basically creates a welcoming pathway for the sperm to get into the uterus. The finish line, in a way, moves just a little bit closer. So we have this really smart three-part strategy. But there's another massive factor at play here. It's not just about the quality of the strategy, it's also about overwhelming, staggering quantity. Just take a look at that number for a second. 250 million. That's the average number of sperm in just a single ejaculation. It's an absolutely astronomical figure, and it really makes you wonder, why on earth would you send an entire army when the mission only requires one single soldier? Well, the answer is that the harsh environment isn't a bug, it's a feature. That acidic obstacle course is actually nature's ultimate quality control system. It immediately filters out the vast majority of the contenders, making sure that only the absolute strongest, fastest, and most resilient candidates even get a chance to move on to the next stage. So what about that tiny fraction that actually survives the initial acid test? Where do they go from here? What's waiting for the champions of this first brutal stage? This timeline really tells the rest of the story pretty perfectly. After surviving those first few hostile minutes in the vagina, the starting line, the sperm enter the uterus, which is basically a neutral safe zone. And from there, they travel on to the fallopian tubes. That's the real finish line, which is back to that perfect alkaline environment where they can not only survive, but thrive. And this, right here, is the ultimate reward for their incredible journey. Once they reach the safe haven, they're no longer in a frantic race against time. The survivors can actually live for up to 5 days just waiting patiently for the egg to arrive. They've basically earned their stay in the VIP lounge. So really, it all comes down to this. Sperm survive by using a bit of temporary protection and some incredible speed to get through an environment that's specifically designed to be a filter. The real journey, the real environment for fertilization, is everything that lies beyond that first test. Which kind of leaves us with this final thought to chew on. What at first seems like a huge paradox, a hostile starting point for a very delicate traveler, is actually one of the most effective selection processes you could possibly imagine. It's a system that ensures only the absolute best of the best even get a chance to complete the mission. So maybe it's not a flaw at all, but instead, a perfect design.